Topic is Oracle Java Deserialization Vulnerabilities. And we're going to explain what these type of vulnerabilities are and why they impact your Oracle environment. And the reason we're doing this webinar today is a lot of clients have been approaching us regarding this topic. We've had several clients actually been impacted by Java deserialization vulnerabilities in their environment, and we wanted to raise awareness to the Oracle community regarding these type of vulnerabilities, what they are, why they're important, and what the impact of them is in your environment. Before we get started, I just wanted to give a quick overview of Integrity. So Integrity was founded in 2001, and we specialize in Oracle security for both the Oracle E-Business Suite and other Oracle ERP applications, as well as Oracle databases, Microsoft SQL Server, and other database platforms. There's two sides to our business. We do have a set of products, one being App Sentry, which is a vulnerability and security scanner for both ERP applications and databases. App Defend, which is an enterprise application firewall for the Oracle E-Business Suite. And we also have a services side, and a lot of the information today is from our services professional consulting business that we do on-site security assessments and work with clients to solve security challenges with their ERP and Oracle database environments. And we also have an Integrity research team that does a lot of research and development regarding Oracle security vulnerabilities, and a lot of our work here is from our Integrity research team. So enough about Integrity. Let's kind of delve into the topic. It's very nice to schedule a webinar, send out the invites based on client feedback, and then actually have that validated in the press. So hopefully everyone on the call today knows a little bit about Krebs on security. So Brian Krebs was a Washington Post reporter specializing in security and has gone off on his own and become one of the premier IT security reporters and journalism professionals. He does a lot of research, actually helps track down bad actors in the IT security space. And a couple days ago, he actually released a report on his website, KrebsOnSecurity.com, regarding deserialization bugs in Oracle products and tracking down the San Francisco Metro attacks. So I don't know if everyone knows on the call a couple weeks ago, the San Francisco Metro had a ransomware attack and they were compromised, and a number of their machines were encrypted, and you had to pay money to the attacker in order to unencrypt those. Some research was done both by Brian Krebs and some other security researchers to help track down the attacker. And in that process, they were actually able to compromise his email, and they were able to find a lot of information regarding his exploits and what he was trying to do. And he was actually going against companies and using WebLogic deserialization bugs and exploits against both WebLogic and other Oracle products like Primavera. So he would actually send out links. So here's kind of some of the quotes from Brian Krebs' article. And they actually found emails that he was sending out to companies that if I can attack you and you better plug this hole. And so a lot of what we'll be talking about is these type of vulnerabilities. So before we get started too deep into the actual vulnerabilities, let's talk a little bit about what Java object serialization is and why this becomes a problem. So fundamentally, I've got some Java programs running out there, and this could be within the same program. This is between programs, and these programs can be servlets, they can be Java clients, they can be Java servers. It's very flexible where this runs, because object serialization within Java is just a fundamental capability of that. So I have a Java object in a Java program, and I want to move that over potentially to another Java program. I can write a lot of code to do that, or I can use this feature called object serialization. And so I can actually transfer that object with just a few lines of code. I can transfer it over the network, I can do it in a file, I can write it to the database and then read it back. And there's a lot of capability. So fundamentally, object serialization in Java is just basically to move objects around, to save them out, and so I can reread them very easily or transfer them to another system, etc. So that's the fundamental premise here. And that's why it is quite often used by Java developers to have this capability. So if I actually wanted to do some Java object serialization, what would I do? So the basic process of serialization is I'm taking a Java object, and this could be, as an example we're going to use here, is I've got a payroll system, I've got a person object, so that person object may contain first name, last name, date of birth, things like that. And I want to transfer it over to another machine. I just have to write a few lines of code to be able to do that. So in this case, I'm using some Java classes that are provided by standard Java called Object Output Stream. And in this case, I'm actually going to write it out to a web page. I'm going to connect to a web page and send this information out. And I'm just writing out the person record. And in this case, what it does is it takes that object and converts it into a byte stream. So it's basically just kind of some binary bytes. And then I can actually transfer that across the network. And then I've got another program that's doing the deserialization process. And instead of using object output stream, it uses object input stream. In this case, this is a web server running, so someone's connected to the web page, passed in this serialized object, and then in 3 lines of code, I can now convert that person object back into a person object within the application. As you can see, the in-read object is I'm basically taking that input stream. That was just some bytes passed across the network into the web server. This program was in a web page, it reads it, and now it's converting it back into the person. Now it can use that person record. So this is how easy object serialization is in Java, and this is why it's quite often used. It's very easy to do. I can send objects around. I don't have to now write this out to an XML format or JSON or anything like that. I can basically just now write it out to a byte stream, maybe compress it, encrypt it, do different things with it, and send it across a network, write it out to a file. I can actually put it in the database and then read it back from the database if I want to do those type of things. So as you can see, it's fairly powerful. Don't necessarily see any exploits here or anything like that. This looks kind of pretty straightforward, works pretty well. So what are some of the challenges here, and how does this work when we kind of look behind the scenes? So what's happening in the deserialization process, and this is kind of just the inbound process. I'm not going to worry about how this gets written out. But basically, I've got some program that wrote out this yellow box here, the Java object, and it actually starts now including the class name. So it includes more information than you think it does, because it's just not the data, it's actually the structure. The data is somewhat included in terms of the objects. And if you see in the yellow box, I've got AECD. That's actually the magic characters that tell you that it's, if you look at on the network, what's flying by on the network, any of the IT security professionals who use Wireshark would actually see this if you used up a network sniffer or different tools like those to see actually what's in this Java object when it's being passed in the network or it's been written out to a file. And that AECD is kind of the magic code. So if you're ever sniffing around using Wireshark or other tools, or you actually bring up a file and you look at it in hex, you'd actually see the 2 bytes AECD would tell you that's actually a serialized Java object. And that's very useful in tools like our AppDefend product. We look for that, and then we know what's getting passed in. But you can also see that there's some class names now in this object. And so when this now gets passed into an entry point in the application, again, this is where my read object is. And this could be a web page. This could be just a Java program that's reading a file. And it's reading in now the object. And then it passes it off to the Java deserialization process. And I could talk probably for an hour on how that works. We'll skip over that. I know we've got quite a few different people on the call from different backgrounds, so we won't go too technical here. But the key point here is then that Java deserialization process now calls the Java class. So as you can see, that org my upload, that's actually a Java class that's getting passed in the Java object, and it's actually now calling to instantiate that object. And so it's calling both the constructor and the read object and some other potential methods within that Java class. So now you can see that potentially I can now start passing in classes and call different classes. The myUpload class here has to be of type serializable. So there are some limitations here, but as you can see now, this becomes a little bit more powerful. It's not like entry point is expecting a certain class. You're passing in arbitrary classes. Entry point is processing, and the Java deserialization process is also processing it. So a very key point here is the class names are embedded in the byte stream. This is not hard-coded to say I'm passing in a person record. I'm passing in something arbitrary, and then my Java class is processing that, passing that off to Java, and Java is just processing it. There's no validation. So when I call that object input stream read object, there's no validation to say, oh, he was expecting a person to be passed in. Oh, it's not a person, I shouldn't process it. No, it's just taking that class and processing it and doing what it needs to do to make those objects. And so now this becomes very powerful because the attacker can actually start passing in arbitrary objects. And as you can see in the code in the bottom line here, I am casting it to the person object eventually. So if that read object returns some other type of object and it's not a person, I'll actually get an error. But the key point here is all the work has already been done. All the damage has potentially been done if there is a vulnerability anywhere in that read object method. So again, the attacker can start passing in arbitrary classes, and Java is just processing it, creating objects, and going straight forward. So for a Java deserialization bug, I do need a couple points here. I do need an entry point. I need somewhere where it's accepting serialized objects. And that can be many different things. Web pages do that. Different service-oriented architectures do that. So there's lots of different points where I could actually have an entry point. The most damaging from a security vulnerability perspective is having a web page that would take a serialized object. And that's not that uncommon. So different web architectures do actually use Java serialized objects to pass around things like the state of the view, etc. And so then it's just basically accepting input from the network on a web port, and it's just a web page. I just connect to the web page. I pass in the binary of the serialized object in a post request, and entry point will just take that and start passing that off. So that's the entry point. And so there's many different types of entry points. So you do need to find, if there is a vulnerability, there has to be an entry point. I have to somehow get into the application, and usually that's a web page. But again, now the entry point is just taking what's been passed in and starts processing it without a lot of thought. And there's many different examples of entry points. Again, the most damaging would be a web page, but there's remote method invocation capabilities, Java management extensions, Java messaging services. If you're using any kind of Java messaging services, those use serialized objects quite a bit. Java server faces and Oracle ADF, so you've got custom ADF applications, those use serialized objects for view state. And then any code that's using object input stream with unvalidated or untrusted input is problematic. We'll talk a lot about Oracle WebLogic here, but applications like Primavera, Oracle Hyperion, Oracle Business Suite, those all have known serialization bugs in them. So they're basically have web pages that take in serialized objects. And if there's not precautions taken and protections, I can now start exploiting things. And we'll show you a very detailed example of that in a couple minutes. So the first point is the entry point. So I do need that entry point. I need some way into the application, somewhere that will accept serialized objects. And the second part is I actually need a gadget. So the gadget, this is in Java deserialization, the term is gadget, or also magic classes. And a gadget is actually where my exploit takes place. I need to do something. I can pass it in, I can get it processed through the entry point, but I need now a class behind the scenes that will actually do something that I want it to do. Because the entry point, all that it's doing is just basically taking what I pass in, reading it, passing it to the Java deserialization process, and then passing it to the classes. I have full control over that at this point because the entry point's kind of dumb. It just basically takes in a serialized object, assuming that it was what the developer wanted it, like in this case, a person object. But I can pass in any classes as long as I can create that Java object. And I'll show you a tool that can do that very easily. And now I can just start calling arbitrary classes. Those classes must be of serialized type. Again, there's many of those, but I now have to find one that will actually do something like write out files or do something that I'd really want to do on the operating system or within the Java application. So the key is I need this gadget. I need this thing that will actually do some work for me and actually do something that I would want to do as an attacker of the application. And gadgets are really where the vulnerability is. That's because it's going to do what I want it to do. I have full control over it, and I just have to find one. And there's many different gadgets. People are discovering them all the time. And probably if you wanted to look through a good list in an Oracle environment, there's probably 10 to 15 really good gadgets at this point that people have discovered. A lot of them are getting fixed, but again, people are discovering them all the time. Two of the most common ones you'll hear about are within the Apache Commons. So the Apache organization is an open source development team. that has many different projects going on, and one of the projects is called Apache Commons, which develops common utilities in Java that are used by many Java applications. And in this case, there's actually two of them, one called file upload. So if you want to have a file upload capability within your Java application, you basically just go out to the Apache Commons and download file upload, and you, instead of having to write that yourself, you just use their library. And oh, by the way, there's a remote code execution bug in there. That means I can actually now, if I can call this gadget and control it, I can now execute things at the operating system layer, because it actually does that. As part of the file upload, it's writing out files to the operating system, and I can actually take advantage of that to do this. Again, this bug has now been fixed. Whenever you see the CVE value there, that's common vulnerability enumeration. So that has been opened as a security bug and most likely fixed. The second one is the Apache Commons collections. Again, same thing, that this is now allowing me to potentially execute things at the operating system layer. And this one has also been fixed, but we will actually talk about this in detail and how it's been fixed and where it's been fixed. So it becomes a little bit more problematic. So again, here I need an entry point and I need a gadget. So I need to somehow have something that will accept my serialized input, and then find something that will actually do something that I want it to do. And these two are really good ones, because now I can execute commands at the operating system layer. And that now it's open to my imagination. So if I can execute something at the operating system layer, I can create web pages in your application. I can now potentially do network commands on your server. I can basically delete everything. There's lots of different things I can do. So this is what you're trying to do, is you're trying to find something that is meaningful to the attacker that he wants to do, and these are two really good gadgets to do it. But again, these are not the only ones. People are discovering them all the time. So now I've got my entry point and my gadget. Now I actually have to exploit this. So there is actually a tool that lets me create these objects. So remember, I had to have that Java object serialized. I can write a program to do that myself and spend a bunch of time, but fortunately, nice IT security researchers out there write these type of programs, put them on the internet, so I can actually just call it. And oh, by the way, they they create the payloads for me, so I don't even have to think about I need to use Apache Commons or anything like that. They actually have that all pre-coded in, so I now just have to put in my command here, and if you see the bottom line here, ping integrity.com, that's basically the command now I'm going to execute at the operating system layer. So if I just want to create my payload really quickly, I do have to have an entry point, but they're developing this for me, so I don't even actually do a lot of coding. I just can create the payload, I can find a vulnerability, and then I can send the payload off. So again, a lot of these security vulnerabilities seem very difficult to do in reality, and if you have to hand code them, start from scratch, they are hard to do. Java serialization is not a super easy one. It's kind of like a buffer overflow. It takes a lot of time, a lot of effort, a lot of trial and error to get to work right. But by the way, there's a lot of utilities out on the internet that people have spent time and effort to develop and are very easy to use, so that takes all that effort away. So now I've just created my payload within about 10 seconds, and as long as I can find a vulnerable website with a serialized entry point, I'm off and running. I can basically now start executing commands at the operating system layer. So that's how easy this is. This is not super complicated. I've included a bunch of Java deserialization references here. These are all very technical, so if you want more information about this, I know on the call we've got everywhere from CIOs to internal audit, IT security, DBAs, and other people. But if you want to learn a little bit more about Java deserialization, these are some of the very good references out there that are also mostly focused on Oracle. Again, this vulnerability stretches across all Java applications, and it's also applicable in other languages besides Java. But these are some very good Java and Oracle related references that give you some more detail if you want to get into the bits and bytes of how this works. I'll try to keep this high level because I know there's a lot of different backgrounds on the call. So that's the background. So that's kind of at a 50,000 foot level what Java deserialization is. I didn't want to go into great gory detail at all. Going through those previous references, you can see more information if you want. So now let's start talking about Oracle specifically. So there are a number of deserialization vulnerabilities in Oracle products. And I'm just going to highlight a couple here purposely. We could do this all day long. And we also have some open issues with Oracle regarding this that have not been patched yet. So this is going to continue on for a while. And I'll just highlight one issue here and actually give you an example, and we'll actually do a real life attack against a WebLogic server. So Oracle WebLogic does have a patched vulnerability. It was released in November of 2015, and it affected all supported versions. And the reason this is an issue is WebLogic has a management port. So anyone running WebLogic has the console typically running on port 7001. You can run it on different ports. WebLogic's very powerful, and it actually allows that management port to use different protocols. So I can actually connect to it as the console and do the nice web pages and walk through. But also I can actually pass it a proprietary protocol that WebLogic uses called the T3 protocol. And the T3 protocol actually allows me to pass serialized objects in. Again, very nice feature, very handy if I'm using the WebLogic scripting tool or JMX, things like that. I can actually now pass in serialized objects. Very powerful, very capable. As you can see now, this potentially is a problem, right? I've now got my entry point. I've got an application that will accept serialized objects. Now, what do I do? And at the bottom of the screen, I've included the URL here. We'll be sending out the presentation and the link to the webinar video after sometime tomorrow, so you can actually get all these links. So I've got my entry point. So the key on WebLogic is, why is this such an issue in an Oracle environment, especially if you've got a lot of different products, is because WebLogic is used as the web server and Java container for many different Oracle applications. These are just a few. So if you're running Oracle Business Suite 12.2, you've got the WebLogic console running. If you've got PeopleSoft, Hyperion, Agile, Oracle Banking, Enterprise Manager uses it, Oracle VM Manager uses it. I didn't list them all here, but again, this is widely deployed in many environments, and that's why I brought up WebLogic first. The other issue here is many organizations think, oh, yeah, we've got that WebLogic application running over there. That's, yeah, we did some custom development on ADF, so we actually use WebLogic. What they don't think about is, hey, oh, we're also Oracle Business Suite, and oh, WebLogic's there too. We need to patch that also. So what happens is WebLogic is thought about as the custom applications, but it's not thought about as part of the technology stack of a lot of package Oracle applications either. So when you think about WebLogic, you have to think about it may be deployed in many different places. And so this vulnerability impacts all those. It's just not if you're installing WebLogic to run an Oracle ADF application or something like that. So this vulnerability actually has detailed exploit code and examples available. So I've put the references here, and so if you do want to go out to these two websites or get the actual code that I'll use to show you how to exploit a WebLogic environment, it's all fully downloadable, very easy to use, very detailed instructions on how to do it. I'm going to use Lubia. Lubia, I think, is a Spanish stew, is the name. So it's nothing bad or anything like that. But the code is right there. It's very downloadable. If you look at the other two presentations, those are very detailed. Those will walk you through the bits and bytes of this. Little deep reading. Don't read it too late at night because you'll be sound asleep. But again, if you just download the code in the first link here, it's very easy to use. So now let's kind of pop out here, and I'll go out to so here's an Oracle Business Suite 12.2 environment. So again, I'm just going to my management console here. If you look at the URL at the top, that's port 7001. So this is our Oracle Business Suite 12.2 environment running. It's running a WebLogic server 10.360. And it's basically on our internal network. Fortunately for this type of exploit, most people would not be exposing port 7001 externally. You would not be exposing this console. We do find that though, so it's not totally rare, but some people do it, and you should never be exposing this. This should be internally. But again, anybody on your internal network who can connect to this port can now take over the WebLogic server, which is probably in this case the Oracle Business Suite application server. But again, this WebLogic may be running for Hyperion, PeopleSoft, maybe running custom ADF applications. So I've gone out to, if you go out to Lubia, if I'll actually just do a quick search here, And I think it comes up as one of the first. So it comes up, see, spiced Moroccan stew. But if we go out to GitHub, we'll actually see the code here. So it's just a script. And all I did was just go out to GitHub. And GitHub has a lot of open source projects. So I just downloaded this lubia.py. Again, IT security guys are really nice. They give you full documentation, probably a little bit more than your own developers do in some cases. Tells you exactly how to run it. So this is not rocket science. This is fairly straightforward and fairly easy to use. And so I've downloaded this. I've got it in my environment. And so basically here's the nice command line. Hopefully everyone can read this okay. And so it's just basically going against my server here, again, port 7001. And if you look through the command line options here, it's just basically saying I'm going to install this shell. So it's going to try to connect to the server, port 7001, use the T3 protocol, and we'll actually get it started. And what it'll do is actually use that T3 protocol and exploit a gadget. And the gadget allows me to actually write things out to the operating system. And in this case, what I'm going to do is actually use that gadget to write out to the operating system a web page. And that web page lets me execute operating system commands. So it takes a second to run. So basically now what it's doing is connecting to the WebLogic console. It's using the T3 protocol. And you always love a nice long delay when you're doing a live demonstration. But again, it's now connecting. It's gotten the handshake, it's sent off, and it's deploying the web shell. And so what's happened in the background is it created a serialized object. That serialized object actually called the Apache Commons Collections gadget. And in that gadget allows me to write things to the operating system. And now it actually wrote out a web page to the operating system. In this case, it knew the directory because it's a WebLogic server. Everything is standardized, so you know exactly where everything is. So it knew that for the console, for the cascading style sheets, is this directory. It knew that within the root of the WebLogic server, so it was able to do it fairly easily, and wrote out this web page out to the web application within WebLogic console. So now if I just go up to this URL, so it even tells me the URL, it even builds it for me. I put it up here so I didn't have to retype it, make my life a little bit easier. And so now I can just do a command, and let's just cat etc password. So now that's just basically executing my commands here out at the operating system level. Let's do an ls. What else do we want to do? So we can just basically do anything we want. And so let's just look at our start WebLogic. Hopefully I spell it right. SH. So now it's just basically letting me execute any commands at the operating system level. I could create users, I could change the Oracle user's password at this point. If I knew the old password, I could just do a lot of different things. I can basically go in and do a trust level and actually trust some other servers that could just log in as the Oracle account because I can just create those. So it's a fairly powerful, this is a very powerful attack. As you saw, I just do a couple greps. I am on your internal network. That's probably the one limitation here. And you have not yet patched, you've not applied the patch from the April 2016 CPU for WebLogic, and therefore we got a vulnerability. And that's how easy this is to do. This is not rocket science. I'm not having to create those objects myself and do anything like that. So again, fairly straightforward, but I did need an entry point. In this case, the WebLogic application is vulnerable on the T3 port because it accepts serialized objects. The second part was I found a vulnerability because within, we'll skip back here, within the WebLogic, they're actually running the Apache Commons collection, and that has not been patched yet in this WebLogic environment. So I could actually use this final vulnerability, the last one on this slide here, to actually exploit this environment. So I used both the entry point and the gadget here to do the exploit. And the gadget in this case was Apache Commons collection that allows me to write things out to the operating system. And I was able to write a web page out to the operating system, which then let me execute any arbitrary command using the console website. So again, very powerful. We have seen this in real life to real life clients internally. And we've also seen similar attacks against sites that are using Oracle ADF because there is an unpublished, unfixed vulnerability in Oracle ADF right now. So again, these are real life attacks. These are happening in reality. So how did Oracle fix this? So this was released as an advisory in November 10th, 2015. And the reason Oracle released an out-of-cycle advisory on this was two security researchers actually published a very detailed blog post that I included a link up previously about this vulnerability in many different servers, including WebLogic. So Oracle actually published the advisory a little bit while after that, actually released patches, and then included this as the January 2016 critical patch update. Again, this is only in supported versions of WebLogic, so if it's not under lifetime support, so you have to be at least 10.3.6, 10 or 12.1.2 in order to apply the patch. If you are not, you actually have to upgrade the WebLogic before you can apply the security patch, which is standard for Oracle. So what happened here? How did Oracle actually fix this? So actually Oracle fixed this by not fixing Apache Commons. They actually fixed it by fixing the serialization issue and creating a blacklist of gadgets that aren't allowed. So they basically are now blocking the Apache Commons collections because that library is used within WebLogic. And now in this entry point where they're using serialized objects, they're basically blocking access to certain gadgets. But again, the entry point here is still available. So if someone can find now another gadget within the WebLogic environment that has not been fixed, the entry point's still there. You just now have to find another gadget. So again, you're now playing kind of whack-a-mole here on trying to fix this. So this fixes the immediate problem, but does not fix it long term. This is still potentially a vulnerability for many organizations. So Oracle, before they released the patch, actually released a couple recommendations on how to also remediate this by blocking access. And then they updated saying after you've patched, you should probably also block access. And we can very much concur with that and recommend that you filter and block access to T3. The key is no one really needs to do that except for your WebLogic administrators. I don't need everybody on your internal network. So at least blocking it at maybe a data center firewall level, potentially at the server level, or at any proxy to WebLogic is a way to do it. So there's actually two options here. You can actually block it at a proxy. If you have to connect to WebLogic through a proxy, you can block it at the proxy level, or you can actually do these filterings on the WebLogic server itself. So when you access the T3 protocol, again, you're accessing HTTP, T3, and some other protocols all in the same port. WebLogic has a capability that you can actually now filter out IP addresses based on access to the T3 protocol. So again, only administrators need to access T3. So if there's any way you can actually put IP address filters on that, option 2 is what we recommend now because it's actually the easiest to do. Oracle says there may be a potential performance impact. We haven't seen that in reality. But again, if you can block this just to the application administrators or WebLogic administrators, you can actually now reduce the risk dramatically. Again, trying to get those IP addresses can be difficult, so some of the recommendations are using a jump server, so you use a Citrix server or something like that. You can also block this at the load balancer. There's lots of different places you can block this, but again, if I'm connecting to the console port, that should be restricted as much as possible, and then I'm also trying to restrict T3. So there's no reason that everybody in the organization can connect to port 7001. If there's any way I can block that and reduce access to the console port, both on HTTP, which is just the web pages, but also T3, is very beneficial. Here's the other, put this in for reference, so here's the other Metalink note that talks about the detailed patch information, version information, etc. So you really want to read both Metalink notes in order to secure WebLogic environments. And again, this is not just for standalone WebLogic. You need to be looking at doing this for any application that you're running that's using WebLogic. So that might be Oracle E-Business Suite 12.2, PeopleSoft, Hyperion, Agile, etc. So that's the WebLogic vulnerability. So as part of the WebLogic vulnerability that I just demonstrated to you, I actually used the remote code execution within the Apache Commons collection. So again, Apache Commons Collection is a library used by many different applications. It's just a jar file. You go to apache.org Commons Collection and you download the jar file, put it as part of your application. All the developers, many developers use it. It's very functional. We use it in actually some of our products, including App Sentry. But the problem is that there's this one vulnerability in it. So it was patched. And the Apache team at first said, well, that's not actually our problem. That's the problem of this. You should not be pulling in serialized input that's untrusted. You should be trusting that input before you actually even pass it to us. They did actually eventually fix the bug. But that is a good point that they had, is the gadget's really not the problem. It's you're accepting serialized input untrusted sources. So it really takes two pieces here to tango. But again, people are fixing the gadgets, but you also need to make sure that you don't have untrusted serialized input coming into your applications. So Oracle did go through all its code stack and said, okay, in all our applications, where are we using this Apache Commons Collection? So they first fixed it within the WebLogic. Then they also now started looking at all their other applications. So as part of the April 2016 CPU, they fixed in the Oracle Application Testing Suite. So again, we're now starting to close the gadget holes. But then in July 2016, then they found more places. So there's 23 more fixes within the July 2016 to fix this one vulnerability, because this library is just used everywhere. So they had to go through all these different applications, from transportation management, communications, banking, healthcare, insurance, retail, utilities, Primavera. So they now have to update this library in all these different applications, because at some point these applications are accepting untrusted serialized input. And the gadget was a very powerful one, very capable one, so they need to close that gadget hole. So again, they're just updating the jar file and all these to the latest version. This Oracle Primavera, as I first referenced when we started the presentation on the Krebs on Security article, that was a hacker who was going around and actively exploiting the Primavera bug. So there is a bug in Primavera that has not been published out yet, but he is using this Apache Commons Collection as part of his exploit to do something on the operating system level. So in July 2016, Oracle fixed 23 occurrences of this bug. Again, now in October 2016, they fixed 19 more fixes, and they actually found a couple more cases in WebLogic where it was an issue, in Agile and FlexCube, financial services, insurance, retail. Again, retail was on the last list. It was now, they found it in more places within the Oracle Retail Suite. So again, these gadgets are quite pervasive across the application, especially when they're in very commonly used libraries. So that's Java deserialization at a very high level. And the reason we wanted to do this presentation was give you awareness of what the issue is, what's the impact to the organization. We didn't want to spend a lot of time going through the nitty-gritty detail, because knowing that we've got internal auditors and other people on the call. But in summary, this is a significant issue for Oracle environments, for Oracle products. If you think about SQL injection, that gets a lot of press. This is not quite as bad as SQL injection vulnerabilities, but if SQL injection are a 10, this would probably be rated as an 8. And this is not going to go away anytime soon. This is now gathering steam. So you'll see in the next year or two this getting a lot more press, a lot more issues. And the fundamental problem here is there's entry points in gadgets. And there's many entry points in many applications. No one really thought this was much of an issue when they were doing development. So you've got a lot of huge code bases out there. If you're looking at Oracle Business Suite, it's 250,000 Java classes. How many of those Java classes used unserialized or serialized input that's from an untrusted source? We've got a couple open Oracle bugs regarding this right now. And then there's gadgets. We know of a number of gadgets that are very powerful that are getting fixed, but gadgets are like playing whack-a-mole, because as soon as you fix one of them, somebody finds another one. And when you're looking at large applications, there are many different possible gadgets within those applications that are yet to be discovered. And people are finding ways to now not only use an effective gadget, but potentially do it multiple ways. So you can actually now use reflection to potentially call a gadget that's not even a serialized object. So it's becoming more proactive. More gadgets are coming along. And then finally, these are being actively exploited. This is kind of the new wave right now. We've seen in the last 6 months an uptick of here that we've actually had multiple clients call us saying, hey, we've had a problem. Either someone discovered this or that we actually had a hack and we found things on our operating system that should not have been there. And we think this is how it happened because we're looking at the web pages and the URLs that match up to the timestamps, what's going on here. So we're seeing this out in the wild on these bugs, and unless you're applying the security patches on a regular basis, you are potentially very vulnerable to these type of issues. So to finish up recommendations, I'll give you a couple of tactical and strategic recommendations. Again, security patches are probably the biggest one. Reducing the surface area of your applications is probably the next one. Trying to eliminate these untrusted serialized inputs. But first, at least look at your WebLogic environment and look at it from two perspectives. One is, okay, where is the management ports? Can I limit access to those management ports? Again, because that's still accepting unserialized or serialized untrusted input. And then also look through your technology stacks. WebLogic is running all over the place, and especially if you're running a large number of Oracle products. So WebLogic is very pervasive in the Oracle product suites. And you need to look at where it is, not just that it's a standalone WebLogic server, but if it's Oracle Business Suite, PeopleSoft, Hyperion, those type of applications. Also look at custom development. So if you are running custom ADF applications or other applications either using WebLogic or even WebSphere from IBM, any Java server is potentially vulnerable to this because you may be using serialized input. And then finally, if you're running Oracle Business Suite, there are a number of these bugs in Oracle Business Suite that are in web pages. So our product, Integrity's App Defend, actually protects against these deserialization bugs. So we look at the input and we look for serialized objects in the input, and we'll actually block them because those are not standardly used by the application. So that was kind of an overview of Java deserialization bugs. Again, just trying to raise awareness, give you some things to think about, and give you some background. So when you start seeing these bugs, when you see this in the press, when you see these vulnerabilities being released by Oracle, you at least have a basic understanding what's happening. And I'll turn it back over to Phil to see if there's any questions.
Thank you, Steve. Yeah, there's quite a few questions out here, actually. The first one says, so this is only externally exploitable if you are exposing the WebLogic server console via the 7001 port externally.
Yeah, so Java deserialization bugs can occur just about anywhere. I showed you a very good example of one in the WebLogic server console on port 7001. So if that port is accessible to somebody, again, you should never open it up externally, but on your internal network, most often 7001 is wide open, so I could take over the WebLogic. But within Oracle Business Suite, the vulnerabilities we found in Oracle Business Suite are all in just standard web pages within the application. We believe within the Primavera application, it's within just a web page in the application. Within the ADF application issues that we found and worked with clients on, those are within the application pages. So it's just a standard web page at that point. So this can occur just about anywhere. I just happen to profile the WebLogic server because we see a lot of information on that on the internet. And we've actually seen some actual attacks on that on the internet.
Next question. Can you explain what happened at SF Muni? They say they restored backups after being hit by the vulnerabilities. I'm trying to figure out what they actually restored.
Yeah, so I don't have very much information on the San Francisco Muni attack. We don't know if that was actually through this. The information we have on the Oracle related to that is people have tracked back the hacker who did that, and that hacker has been very active in doing Oracle exploits, and that's the main reason I brought that up. I didn't bring it up because any information directly to that attack. The key issue was the hacker who did that attack that they've traced it back to has been very active in looking for these type of exploits out on the internet. And that's the main reason I brought that up. Are there any other questions, Phil?
Sorry, I had you on mute here.
No problem.
Next question is the best way to fix it a short term is to block T3 via a load balancer?
Yeah, so any way you can block access to T3 or the 7001 port is beneficial. Again, remember 7001 is using both HTTP to do the web pages for the console, but is also accepting the T3. And depending on the load balancer may be able to directly block the T3 protocol. I believe the F5 Big IP does that, and some of the other products do. So yes, any way you can do it is beneficial. But again, you have to make sure that if I'm going through the load balancer, I can't directly access the servers by just going directly to the server in 7001 and avoid the load balancer. So there is a little bit of architecture, a little bit of research required to figure out the best way to do this. And depending on your environment, at the load balancer may work best, at the WebLogic server may work best, at firewalls may work best. So it's just kind of coming up with a strategy. And trying to do this for all your WebLogic servers at once is usually beneficial.
Next one. Our company runs Oracle Primavera. Has this security vulnerability been published?
Fortunately, no. So we have not been able to find any information at this point on the Primavera bug. We believe it's being exploited based on the research that's been published out, that people have found that the WebLogic bug is definitely being exploited, and they've also actively referenced the Primavera bug, but we have not seen any published exploits yet on the internet, fortunately.
Next one. How does your AppDefend product protect against these attacks?
Yeah, so Integrity's AppDefend is a web application firewall for Oracle Business Suite. So it works to protect the web pages of the Oracle Business Suite. So it sits in line looking at every request coming to the application, and also can monitor the responses. And so every parameter passed in, the post parameter and post input passed in, we actually look for serialized objects in that input. So if we see a serialized object, we have a set of rules, and you can allow certain ones if you want, but we'll actually look to see what classes are in there and what serialized input is being passed in, and we can actually either whitelist what objects you pass in, or actually blacklist certain ones like the Apache comments. Most often we just block serialized objects because if you're running externally modules like iSupply or iStore, iSupport, there's no serialized objects used in those. So if someone's trying to exploit a security vulnerability, those would not be typically in those type of modules being run externally. But externally, then we can just block it in general, or whitelist certain modules that might be actually using it.
Next question. Do deserialization vulnerabilities impact the database and its JVM?
That's a very interesting question. That is on our research list to look at. Again, you need an entry point, and you also need a gadget in order to exploit. We believe there are some gadgets within the Oracle database at this point based on preliminary research we've done, but we have not yet identified an entry point. We have not also found anyone who's actually actively researched this either. So we believe that's just, again, a topic that there may be some issues. We're not sure. The Oracle database JVM is limited in the number of classes in there. But again, some organizations upload a lot of libraries and actually have some very functional Java applications running within the database. Those would be the most high-risk environments. We've looked very closely at Oracle Business Suite. Again, Oracle Business Suite is using mostly the standard JVM libraries that are installed with the Oracle database and not a lot of add-ons. But there's some capabilities there. There are some entry points there. But they must also be defined at the PL SQL level in order to access the entry points. So again, open for research. We're planning on looking at it, but have not looked at it yet, so can't really pass an opinion on if there's nothing there yet.
I think that wraps up for the day, Steve. I want to thank everybody for taking the afternoon spending the afternoon with us for an hour or so, and be sure to join us in January the 12th for our next webinar on 12C multi-tenant. So have a great rest of the afternoon and the rest of this week.